complex conjugate a plus bi and a minus bi. So what is conjugate? Conjugate means opposite sign. We have a plus, we have a minus, so they are the complex conjugate of each other. Why do we study complex conjugate? Because when you multiply two conjugate, the answer is equals to a real number. So let's say you have a 5 minus 2i. To make this becomes a real number, you have to multiply its conjugate, which is 5 minus 2i, 5 plus 2i. Conjugate, opposite sign. And then this one you have to multiply negative 4 minus root 3i. Conjugate. And then how about the root negative 7? So this root negative 7 is the square root of negative 1 times 7. Square root of negative 1 is equals to I, so this is a root 7i. And then this one, 1 plus root 5 has no complex number, so I will just add 1 to it, which is 1 plus root 5. And then all you have to do is you add a 0i. So now it is a complex number. Okay, so this is 0 plus root 7i, which is what is given. And then the complex conjugate is 0 minus root 7 and then an I. When you multiply this, the root 7 times root 7 becomes a 7, and then the I times I becomes a I square, which is equals to negative 1. So the answer is just equals to a root negative positive 7. And then the other one, 1 plus root 5, and then plus 0i, and then you have to multiply 1 plus root 5 minus 0i. Okay, next, let's perform the multiplication. So the first problem, let's just do it in a different color. So y minus 2i, and then multiply its conjugate, y plus 2i. And then for multiplication, before we get into this, I want to go over a formula. So for the formula, just allow me to do this in red. Is a plus bi times a minus bi, which is what I mentioned above in the beginning of this video. When you multiply, you have a times a, which is equals to a squared, and then minus abi, and then plus abi, and then minus bi squared. Do you see this? When you multiply a conjugate, these two terms got cancelled. And then you know that I is equals to the square root of negative 1. So when you square both sides, you have a negative 1. So therefore, this is equals to, let me just pull this down so I have more space to do the writing. So this is just equals to a squared minus b times negative 1, which is a squared plus b squared. So this is a real number. Yep, that is what I'm trying to do. Okay, move this up. So now we work on the first problem. Okay, 5 times 5. So this is how you do the multiplication. 5 times 5 is equals to 25, and then plus 10i minus 10i, and then minus 4i squared. When you multiply a conjugate, the two terms in the middle will be cancelled. So therefore, this you have a 25 minus 4 times negative 1 minus 4 times negative 1, which is equals to 29. 25 minus plus 4 is equals to 29. And then moving on to the next problem, let's do this in blue. Negative 4 plus root 3i, and then negative 4 minus root 3i. All right, multiplication, negative 4 times negative 4, negative 4 times this. So we have 16 plus 4 root 3, right? 4 root 3 I, and then we keep on going. We have a minus, and then we have that. We have a minus 4 root 3i, so the two terms will be cancelled, and then minus root 3 times root 3 is 3, I times I is I squared. So you just multiply a conjugate, the two terms in the middle will be cancelled, then this becomes a 16 minus 3 times negative 1, which is equals to 19. Simple, right? Next, we have 0 plus root 7i, and then times 0 minus root 7i, which is equals to root 7i times negative root 7i, that is equals to negative, and then you have a 7, and then I times I is I square, which is negative 7 times negative 1, which is equals to 7. This is a real number. Do you see all the answers that I boxed? They are all real numbers. And then the last one, I have to remind you that 0i is just equals to 0, minus 0i is just equals to 0. So therefore, the very last problem, you are just multiplying two real numbers, 1 plus root 5, and then times 1 plus root 5. And then 1 times 1, 1 times root 5, root 5 times 1, and then root 5 times root 5. That's it. So 1 plus 5 is 6, and then you have 2 copies of that, then 2 root 5. There you have it. Now, let's look at this one more time. So for each answer I wrote, there is no imaginary number I. Do you know why? Because I take a complex number, multiply its conjugate. Every time you do that, the two terms in the middle will be cancelled. As a result, the answer or the product is a real number. There is no imaginary number I in the answer whatsoever. Okay, so if you like the way I teach complex conjugate, give me a thumbs up, a subscribe, and I will meet you all in the next lesson. Signing out.